Set the record when you. All right, and so we are being recorded. Will Irely, I'm the academic dean at the Village School of Naples. I'm really pleased that Mr. Chapman's also on the line tonight. And I'm very pleased to introduce our Singapore math trainer who has been with us since we initiated the program, and about 2.5 years ago now or so. And I like to say it's kind of a joke, but I like to say it's not really not a joke, is that he kind of wrote the book on and how Singapore came to America and why it is what it is. And really, that's what he has, literally has a PhD in Singapore math. I think he might be the only one that's really done that kind of research. I know I'm making you blush right now, Kevin, but it is a fact, isn't it?
I think so.
Yeah.
I'm the only one crazy enough to do something like that, and there may be others now, but I think I was at least the first. Yeah.
So we're very, very fortunate to have the leading expert on Singapore math that trains our teachers. And now I'm very pleased to have this parent workshop with him. And to answer your questions, we'll say the last 15 or 20 minutes or so at the end of his presentation for your questions. Feel free to unmute and ask those questions, or you can type them into the box, and I will in the chat, and I will go ahead and read those. And we will record this session as well, so you can watch back. And we're just really want to help you support your students as we all take this Singapore math journey together and really enhance our whole entire math program. And this is really the first year, because we kind of were interrupted by COVID our first year, and then we got back on the horse last year, but still couldn't get Kevin on campus. And so this year we got him on campus at our opening meetings, and we are off and running this year. And I really feel like we've got a solid start with our program, and we're really starting to see the results, especially with the 6th grade that's just come into middle school, with how much better they're prepared in numeracy and other functions to move to the more advanced. They have such a strong foundation, and we have Kevin largely to thank for that. So here he is, Kevin Mahoney. Take it away. I'm gonna put my screen off and just enjoy your talk here for a second.
Sure. Well, good evening, everybody, and thanks for taking time out of your busy day to learn more about this math program. Before I get going with my slides, I just wanted to introduce myself a little bit further. I currently work as a professor of education up in Maine, and I live in rural New Hampshire, where it could snow at any time. There's already snow on top of the mountains up here, and I know that things are different down in Naples. But I've been an elementary teacher and mathematics specialist for 28 years before I was a professor. And during that time, I led the implementation of Singapore's curriculum and pedagogy in several different schools, and then was, as Will mentioned, I think I was one of the first Americans, or maybe the only American, to specialize and earn a doctorate studying, doing academic research on the effects of Singaporean teaching strategies on American students. So that allowed me to start a consulting business where I work with teachers, with students, and with schools all over the country, and as of late, that's spread internationally as well. So this is a topic that I'd love to talk about, and I get carried away talking about this. So please, I want to make sure that all of you feel free to use the chat to ask me a question. Will read it to me right away. Even just unmute and jump in if you can, and just interrupt me with questions. I know your time is valuable, and I want to make sure that the time you're spending with this topic is of real use to you. So please feel free, interrupt. Let's make this into a conversation as well as we can. Okay, so let me get started with my slides here. I'm going to present for half an hour, 45 minutes, and then open that up to questions for sure. So I'm hoping everyone can see my slides now. So this is just an introduction to Singapore math. I'm giving you painting a very broad brush about the topic, so that you get a flavor for what this is like, and maybe we'll spur further questions and further investigation. I'm happy to come back and do that if you have those kind of questions with parents. Okay, so by the end of the evening, I want to make sure that you're clearer than when you started on what characterizes Singapore's math curriculum. What makes it different from others? What is it known for? I want you to know a little bit about what theory and research say about Singapore's math program. So not just what Singapore says about it, but what researchers in the United States and all over the world have discovered in researching the effectiveness of the program. And then I want to give you a little tour, a little flavor of what does it look like? What do the textbooks look like? We'll do a little bit of math together. I've got a math problem for you to solve, just so you can see what's the same and what's different. A big idea here that I want you to walk away with is that we're still talking about elementary mathematics. There are some different ways that it's being taught, different from probably the way you were taught, but we're still talking about elementary math here. The four operations, whole numbers, fractions, ratios, things that you remember from your childhood too. And then I want to end the program with some ideas, because I'm often asked the question, how can I support my child's math learning? What can I do? And I have some ideas to share with you on that topic. Okay, so theory and research. Let's go back to the beginning and how this all started, because how this curriculum grew has a lot to do with its characteristics. So I don't know if you've been to Singapore, or maybe you're from Singapore. I never have myself, but it's a tiny city-state almost. Very small country, of course, but it is a multicultural country. Singapore does not have a democratic government. Maybe you're familiar with that, but it is. But that makes it interesting in terms of curriculum development. You may agree or disagree, politically with their system of government, but it makes for very interesting, because it's centralized. It makes it a very interesting place to study in terms of how they prepare teachers and how the curriculum grows. So Singapore in the 80s and 90s, they go through a period of restructuring their education system. And this is one of the big ideas that comes out of this resource development idea, is this simple but very powerful idea. And the idea is this, that Singapore considers that, Singapore is a small place. It's an island nation, and there are very few natural resources. There's not a lot of mining or farming that goes on there, not a lot of logging. Those natural resources are basically depleted at this point. And so they consider, they think about restructuring their education system, because a central tenet here is that their greatest natural resource, this is the statement that is made by the Singaporean government for its people, that the country's greatest natural resource is the intellectual capacity of its children. If you stop and think about that for a while, that's a very powerful statement. I'm not so sure that that statement is true here in this country. The greatest natural resource is the intellectual capacity of their children. Now, because this is a centrally planned government, this is not a democracy, this statement actually is now pushed out in all ways throughout the government, including the education system and its Ministry of Education. So if that spurs a lot of redevelopment of the curriculum in all disciplines in Singapore in the 80s and 90s. One of the decisions they make was that in Singapore, there are 4 or 5 different major languages spoken. Not one of them dominates over all the others. They're somewhat equally dispersed. And so what the Ministry of Education decides is that every child, no matter what their home language is also going to learn English. They consider that to be the international language. And so all children in Singapore, very few of them grow up, speak English at home, but they all are taught in English. Everyone is taught in English in school. So now they've got, in terms of math, Singaporeans have to teach math to children. And these children, and they're going to be taught in English, and these children are learning English at the same time. So if you wrap your head around that problem, how do you teach math to kids who are still learning the language? The simple solution is that you want to make math as visual as possible. You want to put as little text into your textbooks as possible. Why? Because everyone in Singapore, all the kids in Singapore are learning English while they're learning math. So you see, that makes Singapore's approach to teaching elementary math very visual for very practical reasons. And that is one of the big ideas I want you to take home today, is that Singapore's approach to teaching math is probably more visual than you had when you were a kid, okay? Now, Singapore develops this curriculum. They work on it for years. They redevelop it every 4 years. The curriculum is not completely reinvented, but reevaluated every 4 years, even now in Singapore. And what happens is that Singapore begins to enter around a little before the turn of the century and then onward. Singapore enters these international mathematics comparison studies, just like the United States, I mean, the Soviet Union, China, everyone is participating in these studies. These studies compare the achievement rates of children, middle schoolers, and high schoolers across the world. And you've seen these studies, I'm sure. One of them is called the TIMSS study. And these studies rank countries in terms of their academic performance in mathematics and science and other areas. And Singapore, the first year that they enter, they come out #1 in the world in elementary math performance. And they stay there. The tests are these studies are done every 4 years, and Singapore stays there almost without fail at #1 in the world for many, many years now. They have dropped in certain places, but they come back to #1, and they retain that top space for almost 2 decades or 3 decades now. So that gets a lot of international attention. Why is that happening? Well, there are plenty of cultural reasons why that happens. And we don't have time to go into those cultural reasons right now, but that's a big part of why Singapore as a nation produces kids who can perform mathematically. There are cultural reasons for that. But investigators still want to know, well, what are they doing in terms of teaching and learning? How is that happening? What's going on with their textbooks? Okay, so researchers jump in. They start to investigate Singaporean textbooks. They're in English, so for countries like the U.S., Great Britain, you know, it's easy to bring these textbooks over to our countries, and they notice right away that mathematical problem solving, is a central activity in the mathematics curriculum, which isn't always the case in the United States. And researchers start to take American textbooks and compare them to Singaporean textbooks, just to see what the differences are. And the results here, these are major studies done by governmental agencies and nonprofits alike, and they agree that Singapore's curriculum, compared to typical US math programs at the elementary level, is more cohesive, more focused, and more deep than typical US programs. What that really means is that the methods for teaching are used consistently throughout the grade levels. Instead of having a method used in first grade and then it's left behind, the methods are used consistently throughout the grade levels. It tends to spend more time, the curriculum spends more time on fewer topics than the US typically. US typically, American textbooks in mathematics are, they can be all over the place. There are 50 different sets of state standards, and that can change how textbooks appear. And so in Singapore, that is not the case. And so they can focus more on what they consider the most important mathematics to learn. So there's also a bigger emphasis in Singapore on number sense and mental arithmetic, the ability to calculate in your head, do mental calculations in all 4 operations mentally, not through the use of lining up numbers in your head and performing an algorithm, but through number sense, which is the ability to take numbers apart and apply strategies to them so that you arrive at a correct answer. The researchers notice that there's a pattern to the way things are taught in Singaporean textbooks. So this is called the concrete pictorial abstract approach. Really, let me boil that down for you. In typical elementary teaching situations all over the world, really, if a teacher is going to teach a new concept to children, what they're going to ask them to do is the children are going to take out a physical object and model the mathematical relationships. Okay, if I'm talking about 3 plus 4, I'm going to have students take out a block that has 3 sections to it and another block that has 4 sections to it, and then combine them. So 3 plus 4 is 7. It's a model, so that it's not just this abstract number written on a board. There's a model. Okay, that's typical everywhere, even in Singapore. And then what a teacher would do is once students are familiar with that concrete idea, then they'll move them to the abstraction of algorithms and mathematical concepts and that kind of thing, from concrete to abstract. Okay. In Singapore's approach, largely because of this language situation that I talked about earlier, they inject a middle ground, a middle step, a support, a bridge between the concrete and the abstract. And that is that in Singapore, they often ask students to make diagrams. Diagrams are not exact pictures, lifelike drawings of what's going on. They are more abstract, but they're a little more concrete than simple algebraic notation, you see. So this bridge between the concrete and the abstract is something that's very typical about Singaporean teaching. And the materials, the textbooks that are used are a little bit simpler, clearer, less decorative, much more meat and potatoes. Here's the mathematics. Everything on the page matters. Those kinds of, and American textbooks tend to be more decorative and engaging looking to students, which actually can be a distraction to them. So you see researchers compare American textbooks to Singaporean textbooks, and these are some of these qualities that they discover that are different. Now, because of all these visual teaching approaches and the different emphases you'd see in Singapore, that typically allows Singaporean kids to be working with content that's generally a grade level ahead of most US classrooms. That's not always true. It's not true in every single situation, but on the whole, in my experience in schools around the country, schools who start to use Singaporean curricula, they tend to, their math, after a while, their students become more adept at understanding challenging concepts through visualization. And so they're able to access more challenging mathematics at younger ages. Okay, so let me show you these characteristics. Let me just display some textbook pages for you so you get a feel for what this really looks like for your kids. Okay, so here's a textbook page. Think to yourself, what's this page about? What mathematics is this page about? What's the topic here? And if you saw that this is a page that's talking about multiplication and division, of course, you're right. Notice here that there are multiple representations of this idea of multiplication, of equal groups being added together repeatedly. There are these bowls of apples, okay, then the child is talking about it, and yep, there's a little bit of text there, and then they're displayed again in this very powerful mathematical model called an array, which really lends itself to multiplication and division quite well. So you can see simple and clear, but powerful mathematically. Here we're representing the number 3,274. We've skipped ahead a few grades here. Now we're dealing with bigger numbers, 3,274, but look at how this number is portrayed visually in several different ways. So these are like chips. They're almost like poker chips. They're physical objects that you'll see in your child's classroom. They call them number discs, and they're put out on a mat, like almost like a dinner table mat, but it has columns for the place value columns. So you can see here I've got 3 thousands, 2 hundreds, 7 tens, and 4 ones. 3,274. Here is the same number broken down into what we call expanded form, its component parts. And here again, this would be shown physically to kids in the classroom on these number cards that show how you can put these 4 components together to make the number 3,274. And you can also separate these cards into their component parts. You see, a lot of typical US textbooks would not go into this depth or show children multiple ways to understand this number. It may look simple and simplistic to you, but it's actually mathematically very powerful to grow up thinking that that numbers are allowed to be taken apart and put back together. They're made of components. In some ways, this produces an idea that numbers are like Legos. They're made of parts that you can rearrange. This is very powerful, and it certainly was not part of my own elementary mathematics education, where we just identified that's the ones place, that's the tens place, that's the hundreds place, that kind of thing. Okay, so here we skipped ahead a grade or two, and we're looking at good old standard addition. Yes, your children will be learning these things just like you did, not in the same way, but the same topics. Okay, so here the child is given a problem. Remember the central idea of problem solving, and we're adding up these two amounts. And first, the child's going to make a model of this problem. So there's our first number, 200s, 3 tens, 6 ones, and we're adding to it 300s, 6 tens, 2 ones. So physically moving these chips and adding up the numbers, that's how it starts, with that concrete and pictorial representation. Eventually, we want this to go away. Eventually, we want to teach children, hey, there's a fast, accurate way to understand this, and that's what we would call the standard algorithm, just like you and I learned. Except what your child's going to learn that's different is this process has some meaning to it. So 6 ones and 2 ones would make 8 ones. 3 tens and 6 tens, there are 9 tens in this number, and 300s and 200s, there are 500s. 500s, 9 tens, 8 ones. So you see, a child has got more conceptual understanding, especially than what I did when I was a kid, and maybe for you too. Okay, here's a page from 4th or 5th grade. We're talking about equivalent fractions here. Again, you see this very visual approach. They're still learning to do the things that we learned, but they're learning with a concrete, pictorial, abstract approach, and it's very visual. Okay, so there's some key characteristics here that I really want you to remember. When someone that you don't know, or someone that is, you're talking about this, your child's school, and what's this Singapore math really all about, talk about these points. The concrete, pictorial, abstract approach. That's very important. A lot of visual teaching strategies, and now you know why that is the case. Multiple representations, we saw that in those textbook examples. Problem solving and mental arithmetic are pushed more than the curriculum that is typical in the United States. There's more problem solving and more mental arithmetic in this program than there is in typical US programs. And the last point to make here is that there's a balance here in this curriculum. You see, in the US, and in many other countries, there's debate, ongoing debate about what's the best way to teach mathematics. There's a lot of debate about what's the best way to teach history these days. And mathematics is not left out of these different kinds of arguments. Is it best to learn as I did as a kid? I was taught, and you were probably taught this way too, to learn these procedures and master these procedures so that you can become fast and efficient with those procedures. That's important in mathematics. That's what I was taught. I remember, and I tell this to teachers too, I remember when I was in 6th grade, I was told to memorize this little poem about dividing fractions. Do you remember how to divide fractions? Maybe you haven't had to do that in a while, but to divide fractions, you invert the second fraction and you multiply. So I was taught this poem. Ours is not to wonder why, just invert and multiply. I mean, you can hear it right in that little poem. Don't think about it. You're not supposed to know what's going on. You're just supposed to be able to work through these procedures quickly and accurately. Now, Singapore is saying, and many other countries now are starting to say, look, that's not enough. That procedural fluency, that's good. We need to teach that to children. It's very important. But they also have to understand conceptually what they are doing. And so this curriculum tries to balance those two things so that your children are learning conceptual understanding, why it works, and they're learning procedural fluency, how to work fast and accurate. Okay, both of those things are important. Think about an automobile. Okay, is it better to know just how to drive, or is it better to know how the car works and how to drive? It's better for everyone if you know how a car works. You don't get taken by that mechanic. I don't mean to offend anybody who's a mechanic, but you know what I'm talking about. And the same is true here in mathematics. It's best to understand, for a child to grow up understanding how it works, that mathematics is supposed to make sense, and still learn those fast and accurate procedures. Both of those things are needed. And that was not the case when I was growing up, and likely was not the case when you were growing up. This is new. And this conceptual understanding will be tested. It is now part of the SAT. It is now part of state testing. Having children explain how something works or why they know that it works. This is important now, and it wasn't necessarily when I was growing up as a kid. So these are some of the key characteristics, and I hope that these are things that you understand a little bit better after having presented some on this. So let me give you now, we looked at these big characteristics. You saw examples of textbooks, okay? Now let's do some math, okay? So what I want everyone to do is get out a pencil and paper because I've got a problem for you to solve. And I'm not watching you do this problem. You don't have to worry about, I'm not going to ask you for your answers or anything like that, but I really do want you to tackle this problem and tackle it any way you want. And then I'm going to show you how your children will be taught to tackle a problem like this, okay? So first of all, think about this, 45 plus 8. Remember, I told you there's a big emphasis on mental arithmetic here. So do that problem in your head, okay? I don't want you to write down these two numbers in a column or even do that in your mind's eye, but think about how you could add these without doing that. I'm just giving you some time to think here. Okay, now there could be lots of ways that you could tackle this. I'll tell you the way that I tackled it, okay? And maybe that'll compare to the way you tackled it. All right, so I added 5 and 8. I knew that 5 and 8 is 13. I have that fact memorized up here, okay? Then I took 40 plus 13. So the answer is 53. Now you may have thought about this in another way. You may have thought about this as, I'm gonna take 5 away from the 8 to bring this number 45 up to 50. And that would leave me with 3 left. So 53. There are lots of ways to tackle it. So kids, your kids are going to be asked to do a lot of mental arithmetic and talk about the strategies that they used and learn strategies from each other and from the teacher. They'll be asked to do this quite a bit. And you can see already how maybe I've emphasized, you picked this up, that memorizing those simple math facts, like knowing what 5 plus 8 is, that's going to be important, and that's going to be a key area for you to help your child. Okay, so you've seen a little bit of mental math. I'll go through, skip these more mental math problems and demonstrate one other approach to math work, and that's going to be these diagrams that I've been talking about. Okay, so problem solving is a core activity, and I've got a problem for you to solve. Okay, again, with your pencil and paper, I want you to take some time and try and engage with an answer to this problem. No one's going to check your work, but really give it your all and try and solve it. Bullfrog caught 435 mosquitoes and dragonflies today altogether. Okay, she caught 4 times as many mosquitoes than dragonflies, though. So how many more mosquitoes than dragonflies did she catch? So again, I'll give you a minute here to write out some answers. You can make drawings, you can use algebra, you can use arithmetic, you can phone a friend, you can pause, if you're watching the recording, you can pause and then spend as long as you want on this, but I'll give you some time here. I'm just keeping an eye on my watch. Okay, So for the sake of the presentation, I'll move forward and show you what would happen. So remember that base idea that in Singapore, they use a lot of visual teaching approaches. They use that bridge between the concrete and the abstract. Well, this is one example of where it would happen. So children could be given this word problem, okay? And what your child is going to be taught to do here is to draw a diagram, a model of what's happening in this problem before they go ahead and choose an operation and do their calculations. Let me show you what I'm talking about. Okay, so they might write an answer sentence here. The bullfrog caught blank, more mosquitoes than dragonflies. So they're focused on what they have to find out in this problem. And then they're going to draw this model here. It's called a bar model, not because it's talking about about bars, but it's talking about these rectangles. Okay, so this rectangle is supposed to represent all the mosquitoes, and this is all the dragonflies. It's not a really good model yet, is it? Because they're equal numbers, and we know that there are a lot more from the problem. We know there are a lot more mosquitoes than dragonflies. So right now there are 3 times as many mosquitoes than dragonflies, and now there are 4 times as many mosquitoes than dragonflies. Okay, so now, this is getting a little bit clearer here. I can start to see these quantities, and I know that altogether there are 435 bugs. Okay, I also note here the child's also going to draw a question mark. The question mark on this model shows exactly what I'm supposed to find out in this picture. You see children all over the world really struggle with word problems. This is not just something that is common to the United States, or I struggled with word problems when I was a kid. Certainly kids all over the world struggle with this because it's a challenging task to translate a story into mathematical expressions. So this is a concrete way to do that. And the child is asked to put a question mark over the part of the model where the answer to the actual problem will be. Okay, so altogether, there are 435 bugs, but we need to know how long it is from here to here, how much it is from in those 3 boxes. So I hope you can see here that there are 1, 2, 3, 4, 5 equal boxes. They're all equal. And when we put them all together, we have 435. And we can use division to find out that one of those boxes is 87. You can do the division mentally. There are mental math strategies for doing that problem, or you could do it with long division. Maybe you remember doing that as a kid. Okay, but we know that one box is worth 87. Okay, so we put 87 in all the boxes. And our question mark tells us that we don't need just one of these boxes. We need 3 of them. That's how many more there are, more mosquitoes than dragonflies. So we need 3 groups of 87, which is 261. So the bullfrog caught 261, more mosquitoes than dragonflies. So I'm hoping that you see through this demonstration that one technique that'll be taught to your children is this idea called bar modeling, where they can draw a map. They can draw a model of a complex problem that helps them solve the problem. And I hope you also see that even though kids aren't told this, that what we're looking at is algebraic reasoning. 5x is 435, x equals 87, and we need 3 x's to solve the problem. This is algebraic reasoning, and this is definitely something that is a crucial part of this kind of technique. We're teaching kids at young ages to think algebraically. So when they get to 6th grade, 7th grade, they can throw out these diagrams. They're meant to become obsolete and replace them with algebraic representations, okay, which are definitely more abstract, but are grounded in drawings like this and models like this. I hope you can see how that would be helpful. Okay, so to close my presentation here, let me just make sure that I try to give you some of my thoughts about supporting your child in this curriculum, okay? Before we get to my specific techniques, I want to underscore the importance of memorization of math facts. And this can begin in kindergarten, in 1st grade, where children can start to memorize their addition and subtraction facts. And then in 2nd grade, 3rd grade, 4th grade. By the end of 4th grade, they should have all 4 operations memorized. Now in Singapore, this is a cultural tradition. Okay, just like we read to our kids a lot in the States. In Singapore, they read to their kids and they also make them memorize their math facts. It's just cultural. So this is something that that the school, that village school, Naples, is relying on you for. Not completely. They'll do lots of work with math facts in the classroom, but you can really help. You can really help by helping your child memorize these simple math facts, the multiplication, addition, subtraction tables. So then let me get to some more specifics you can do with your kids. So when your child comes home from school, once in a while, maybe even once or twice a week, ask them to teach you something that they learned in math class. I have kids of my own and they gave me that, what'd you do in school today? Oh, same old thing. What'd you learn today? Oh, nothing. I'm used to those kinds of answers, but teach me is a different strategy, a different question to ask. I want to know what you were learning in math today. Will you teach me? Will you show me? Okay. And that can open up a great conversation and allow your child to rehearse, to practice, to articulate the concepts that they're learning and the skills that they're learning. So that is vital. It's very important. Teach me. Informal math is a great way to get kids starting to think about, applying mathematics to your family life. Not all the time, not every 10 minutes, but bring that in as often as you can. Ask kids, how much do you think this thing weighs? How much do you think two of them weigh? How long do you think it is? Estimating measurements. Show me, okay, how much you don't want to eat your mashed potatoes? Okay, I want you to split that into fourths and you can eat 1/4 of your mashed potatoes tonight. Okay, how can you bring informal math into the home? Cooking is a great way because you're dealing with measurements and you're often having to change those measurements or double or triple those measurements. So there's a lot of easy, practical ways to work with math informally. Talking to your children about persistence and how important that growth mindset is. There are books written on this topic, but helping them understand that if they don't understand something at first, then their effort will eventually bring them to a place where they can understand. It is not, trying to make mathematics, take it out of the realm of performance sports and bring it into the realm of slowly increasing your understanding through hard work, through patience, through effort. That is the mindset that is really going to make a successful math student. Having teaching your children, even at early ages, to talk to a teacher when they don't understand. It's okay to make mistakes. It's okay. And if you're not understanding something at home, it's okay to go in the next day and talk to the teacher about, can you show me again? This is an incredible skill to teach elementary age children, because they may or may not be comfortable with it. But if you can teach them through practice and repeated attempts to be comfortable with asking their teachers for help, that is a skill that pays huge dividends when you get to junior high or middle school and high school, where it is tougher to do those things and it's harder to learn how to do it when you're older. Okay. The chef versus the cook. This is a way that I have of trying to help you understand the benefits of a curriculum like this. So I would consider, my wife is someone that I would consider to be a chef. She is not a professional chef. She sometimes is paid to do that, but not very often. And I'm more of a cook. So I can look at a recipe and I can follow the recipe, and when I follow the recipe, it usually comes out pretty well. I'm happy with it. I'm pleased with it. I'm satisfied with what I've made. Okay, I can follow a recipe. I enjoy it. My wife, though, she goes about cooking in a very different way. My wife understands all the ingredients. She'll think to herself, I think I'd like to make something Italian tonight. So she knows the different ingredients and how they go together. And so she can pull from whatever we have in the house and create a meal that has nothing to do with the recipe. She's a chef, okay? Now apply this idea to mathematics. A curriculum like Singapore is like the one that is being implemented here at the village school. It balances conceptual understanding with procedural fluency. Okay, and that makes a young child into a chef rather than a cook. And that's important for high school level success in mathematics. You know, there's a huge drop off in high school and in college in terms of the number of math courses taken. There's a lot of the country is shying away from taking any more math than they have to. Why? Well, because they're cooks. And the recipes are definitely getting more complex. I hope that this makes sense to you. Teaching a child all of that work with mental arithmetic, with modeling, with articulating their understanding, that makes them into chefs. It gives them number sense. It gives them confidence. It gives them excitement about solving problems. Why? Because they have tools at their fingertips and they can think for themselves mathematically. These are some of the intangible, maybe, products of a curriculum that balances conceptual understanding and procedural fluency. Okay, so I'm going to stop sharing right here and get to see if there are any questions out there for me. I hope that this presentation was informative for you. I hope that maybe even made you think about things you hadn't thought about before, but it gives you a broad strokes look at what this curriculum is and what it's good for. Okay, let's see. I'm looking at the chat here.
So Kevin, I want to say thank you very much first before we start. And there were a couple things in the chat. And I also wanted to say thank you for mentioning the advanced factor of the Singapore curriculum, because we had a number of middle school parents. I sent a letter out actually to explain that it's one of the things that really wasn't, I don't think, articulated very well, you know, that advanced feature, that you wind up a grade level ahead, especially the kids that are in our elementary school right now. By the time they get to middle school, we're already seeing that in our middle school where they're about half a year ahead right now. So for example, our 8th grade math students are still finishing the 7B Singapore book and they're getting ready to start in the 8A Singapore book. So they're about, you know, almost half a year ahead. Even in the college prep level of math, they're ahead. And because that 8B book, that's all Algebra 1 concepts basically. So they're going to be actually getting a taste of algebra before they move on to high school into Algebra 1. And as you pointed out, they're already thinking in those algebraic terms.
Yes.
With breaking down those numbers into their component parts, and really they don't realize that they're solving for X because it's never said you're solving for X, but they're solving for X. So they're already pretty proficient at linear equations by the time they're heading into algebra, whether they know it or not. So I will look in the chat really quickly, and if I'll too as well. I saw that are we seeing the students are enjoying math and Singapore math from your perspective and the teachers at Village School? I can answer that question. That's one I wanted to take because I don't know how much time you've spent in the class. I know you spent a little time in the classroom, but not as much as I have on a day-to-day basis.
Sure.
And I can tell you that the kids have a great deal of fun, especially in the lower school through 5th grade. I've been spending a lot of time there these past few weeks, and they really look forward to their math sessions and to using those chips and the discs and breaking the numbers apart and playing the games and the way the teachers lead them through, and being able to speak up and represent and articulate different representations of solving the same problem. Just because one child solves it one way, another child gets to stand up and solve it in a completely different way and still have the right answer. And that really gains that whole wealth of knowledge. All the students learn from that hey, there is more than one way to look at this and solve it, and that's multiple representations are so important. And I love seeing them having fun with that. The fun with the funny drawings and the visualizations and the way they can do things is really cool. So,
Yep.
so that I can say to the parents that I definitely see that enjoyment. I would say that when they get to middle school, it becomes a little more like there's still a lot of the same concepts are there, but it gets a little more serious. They're dealing with bigger concepts and bigger numbers. It's not quite not quite as fun, but the teachers do their best to make it fun. And I was in the classroom the other day seeing that firsthand as well, that they were really, there's a lot of laughter going on, even when mistakes were made. So that was good.
The way I think about it, Will, is that they're, when you teach children from a young age, that you teach them a number of different tools and strategies, they feel confident. They have a toolbox. I mean, think about it this way. Imagine if you go into a repair situation, you've got to fix something in your bathroom, and you go to get your toolbox and you got 2 tools in it. You are not going to want to do that repair job. If you go into that repair job and you've got 10 tools, you're much more comfortable going into that repair job. You're probably going to have what you need to fix that situation. That confidence and comfort leads to actual joy, because now we can solve problems in a playful way. I know 2 or 3 different ways I can solve this problem. Which way might get me there fastest? Which might be the best way? That confidence bubbles up in smiles and joy. I'm not talking about Disney World in the math classroom here, but I am talking about comfort with mathematics, which leads to curiosity, further investigation, and even joy. Yeah,
I agree. There was a parent that said they were very happy with your model because they could have used that actually last night when they were helping with the math. So that was good.
It's interesting that there are a few techniques that American teachers don't know. They were developed in Singapore. They're used in Singapore, and having teachers learn them is really important. And parents too, if you're interested, that's something I'd be happy to teach parents how to do and teach them about. I even have an online course for parents around, sinking yourself into the math curriculum, what it's really taught like, and the big ideas behind it. So I'm happy to talk further about those topics.
So if anyone else has some questions tonight, you feel free to unmute, or if you are shy and you just want to type it in the chat box, we'll take it either way. That catches us up on what was in the chat box thus far. So if there is any other questions, this is the time to ask. And I really appreciate everyone that's here tonight. And I just see that there is a new message. Let me see, what did you catch that one there? Oh, a couple of them are there extra math programs to supplement the classroom that you would recommend to keep the excitement of math growing for school that could be worked on at home, like, for example, math clubs and things like that?
Yep. That's a really interesting question. I do get that question quite a bit. And my thought on external math programs is to really look at them very carefully. There's a big business in Singapore amongst tutors who will work with kids extensively outside of the classroom. That's very, very commonplace in Singapore. But programs here in the States tend to, but if I'm going to open up a branch of a math program, after school math program for kids, and I'm going to make money doing that, then what I need to do is I need to get kids in from everywhere. That means the kids are going to be coming to me from many, many different kinds of math programs with really different levels of mathematics, conceptual understanding and procedural fluency. So what I need to do is then take these kids that come from so many different directions and build a standardized stepping stone process. And usually what these programs do is they put a very heavy emphasis on procedural fluency. Do these procedures right, move up the ladder. Keep doing the procedures correctly and practicing them, move up the ladder. This is great. This really helps kids with their procedural fluency. And that can build confidence. The trouble is, though, that these programs often don't, because they've got kids from all over, they don't take the time to teach that procedural fluency. And your child in this school is going to be asked to master that conceptual understanding, really is what I'm talking about, not procedural fluency. So a child can be performing, can be doing calculations at a high level quickly and accurately, but you ask them, what does this mean? How does this work? And they don't know. They think they're performing at a really high level, but they actually are lacking in some in some pieces that are going to be used and emphasized in school. Do you see the challenge of these outside programs? They do some things really well, but they often don't have the comprehensive approach that the school is taking to teaching math. So
it's very one size fits all.
It's that's a great way to put it, Bill. It's one size fits all, and that's good to a certain level. An individual tutor, if you interview them and talk with them, they can put together a much more comprehensive learning experience for your child, and that usually can enhance a child's learning, especially if they're excited about math. Yeah.
So one of the things the parent followed up with is parent resources to help them understand the processes and methods better so they can support at home. I can share the links. They can purchase directly. Singapore you can buy Singapore materials directly from Singapore Math Incorporated here in the USA. And I can share that link with parents. And they do have a number of resources that might be, that you can look into there. And Kevin, I'm sure you have some that you might be able to suggest if you wanted to send anything to me, even if it's just, grade level or division specific. And then I could share that with parents as well, if you have any resources that you would recommend.
I'd be happy to do that. Yep.
And then I can get that. I'll push that out to parents with this recording, and
Sure.
That will help them get those in their hands.
Sure.
And there was a big thank you. Okay, great. I think we answered that question. Any other questions this evening? We have a few minutes left. We'd be happy to answer anything that if there's something that's going on. Let's see, where's it? I thought I saw something about fourth grade specific. Oh, no, that was something else. That's all I have so far. I guess everybody. Oh, one new just popped in. Somebody thought of something. Here we go. Let's see. Thank you for this information. How popular is the move to Singapore Math among schools?
Oh,
That's a great question. You can answer that, Kevin. You know that.
It has become around 2000. It was very rare. That's when I was starting to implement it in a school where I was teaching. But at this point, it has grown in popularity internationally. So I would say that Singapore's approach to teaching elementary math is considered a world-class curriculum. That the village school has adopted the best known elementary mathematics curriculum across the globe. Implementing it well and effectively, that's always a work in progress. Teachers always have to be improving their practice with that. But it is now in the situation where in the United States, if any school, public school or private, is thinking about, oh, we need a new math textbook, we need to revamp our math program, that a Singaporean influenced math program is definitely going to be on the table. The school may not choose that, they may choose another one, but it's become that popular is the wrong word, but it's become that vital of a choice. Math standards across the country are incorporating some of these teaching techniques that the village school teachers have learned, and it's become a major influence in U.S. math education.
So here's a great question, and that was a great answer. Thank you for that, Kevin. I would also add to that it is it's kind of the gold standard among the finest independent schools. Yes. Singapore Math, and that's one of the reasons why Mr. Chapman and the village school wanted to move to the Singapore system, because when you look at the top independent schools in the country, they have one thing in common in their math program, and that is the Singaporean elementary foundation from K through middle school. So that's definitely there. If a student has math disabilities or challenges and started Singapore, say in like the 5th grade, how can we help them catch up, kind of best succeed, based on that? Because obviously, they started out with a few years of not having that, and then they're kind of switching into a new way of thinking.
Sure. And that, you've got to give that some time, for sure. That can take a number of years for that child to gain that new way of thinking. But one of the first places I would think of in a very direct, concrete way is helping that child memorize those math facts. It may seem dry, it may seem like a unsurprising kind of answer to you, but often for children, they think of their math ability as their ability to memorize those facts. We know it's way more than that. It's much more broad than that. We try and teach that in the classroom. But that's the first confidence booster that I use with kids who are struggling or feel like they're a little bit behind in math in the later grades. Let's get those facts memorized. That gives them confidence in the classroom. That gives them openness towards these new ideas. And that's usually a place to get the ball rolling. For a student in middle school who is struggling with math and it's just new to the curriculum, there are plenty of tutors out there who are trained in these techniques and can use those techniques with students. And certainly discussing the situation with the school in terms of extra help and support for that student is definitely an important step too. So all those things together can come together to really help a child get caught up there. Yeah.
That's a great answer. I agree. And also, I would just say, and Kevin, if you can chime in on this if you wish, but because you probably have plenty of experience in this area as well. Personal experience, my brother Scott struggled with math, and it's something that everybody expects. You're going to learn to do math, this type of math, fractions in 3rd grade, and you're going to do, you're going to know your and some students just get it. It clicks in later or earlier, depending. It's just like, we don't worry about if our child walks at a year old versus 16 months. Usually we're not freaking out, but we freak out if they don't have algebra down by the time they are in 8th grade, So it can click in. And my brother was a perfect example. He was a C and D math student all the way through high school. Then my dad pushed him to take calculus his freshman year in college. He wound up with a great professor who had generous office hours and was willing to spend a lot of time with his students. And all of a sudden, the right teacher at the right time and the right moment for him it all clicked in. And now he is an astrophysicist with a PhD and is a professor at the University of Oregon. He's also worked for Keck and Gemini. He was the head of the National Science Associate awarding grants on the Hubble telescope. But it didn't click in for him until he was a sophomore in college, and it just all of a sudden he thought math was just not his thing. And then he had to be forced and pushed. And then all of a sudden it's his thing. It's what he does with his life now. He's doing stuff I can't even comprehend mathematically, in astronomy right now. I think as parents, we all, we got to keep up. But sometimes you just got to take a breath, and it's all going to be okay. And know that you're in the right place. We have all that. Your child is known and nurtured at the Village School in a way that we're there to give that support. And advocating, as Kevin said, is the way to go. We're there to support and help every way we can, every step of the way, to make sure that those gaps are addressed.
Yeah, it's really about progress. Your child may not be where you want them to be, but are they making progress? Is the teacher reporting to progress? Because that's the growth you need to see. That the brains cook at different rates. And then I got 2 sons; those brains aren't done cooking yet, and they're in their 20s. So it takes a while. And developmentally, these things can certainly happen at different times in people's lives, for sure. I've seen it many, many times. I totally agree with you, Will.
Well, I thank you so much. That wraps us up for tonight. If you have any other questions, Kevin and I are in constant touch. In fact, we're going to be in touch next week, working out a schedule for some professional development for our teachers as the year progresses. So, I just want to thank you all for taking the time tonight. This will be recorded and will be shared again online, and we'll have those additional resources for parents that I talked to about. I'll links to Singapore Incorporated, and also Kevin will share some resources with me, which I'll also pass along to you as well. I really appreciate your time. Thank you for your support of the Village School and Knights for Life. Thank you, Kevin. Good night.
Good night, everybody. Good night.